Welcome to our lesson 6.2. Today we're going to be talking about the law of cosines. We've used the law of sines previously. The law of cosines can also be used to find a side or an angle for any triangle, not just a right triangle, but any triangle. The relationship this time, however, is a little bit different, where when we use the law of sines, we needed a angle side pair. To use the law of cosines, you don't have that angle side pair. In fact, this is the way the law of cosines works out, or the way it shows for this triangle. It says that the square of side A, the square of this side, is equal to the sum of the squares of the other two sides, b squared plus c squared. And if we leave that alone, I know that you'll see the similarities to the Pythagorean theorem there, folks. Length of side squared equals sum of lengths of other two sides. However, since this is not a right triangle, we have to do a little adjusting to this. And the adjustment factor is this. You subtract 2 times the lengths of sides B and C multiplied, so the product of B and C, and then multiplied by the cosine this time of the angle opposite of the side you're interested in. So I want to just go through that one more time. There is a relationship between the side length and the angle, only this time one of them is missing. Okay? We can use this law of cosines to solve for a side, just the way it sits here. And this will solve it for a side. We can also do a little bit of algebra, which I'd like to do with you now, to show you how we can use this to find a missing angle. So I want to ask you to think about doing this. We want to get this term, cosine A, all by itself. And I would ask you to just be real careful and remember that this -2 minus 2 times B times C, this is all one term. So before we start dividing things out of here, we got to take care of the addition and subtraction. So I'm going to do a little bit of algebra here, and I'm trying to get this by itself. A squared, well, I have to subtract off a B squared and a C squared. And right now what we have left is minus 2BC times the cosine of the angle. It's the cosine of the angle that we want to have by itself. So the next order of business in this algebra problem would be to divide both sides by -2BC. And if we do that, we will have the cosine of our angle A. And you'll know, once we get here, to find the angle, we would just do a cosine inverse. So this can be used to solve for a side, just the way it looks, or to solve for an angle. Solve for an angle using this format. Okay? We have some examples that ask us to do both. We need a side in this triangle. You can see that the x is what's missing here. What you need in order to do that are two sides and the included angle. And I'd ask you to look real carefully at our triangle. You will see we do not have an angle side pair. Okay? We don't have that. That's why the law of cosines comes into effect here. What we can do to find that side length, though, is remember that the law of cosines says missing side square is equal to the sum of the squares of the two sides that you know, 5 squared plus 9 squared, minus that correction factor, 2 times the two sides you know, 5 times 9, times the cosine of the angle that's opposite the side we need, so the cosine of 120 degrees. Our calculator can do this work for us very quickly, so I'm going to get mine called up here, and I'll tell you, it's my belief, it's my finding over years that you will be better off putting this whole thing into your calculator at once rather than doing it in pieces. So if you are using your telephone as a calculator, make sure that you know how it's doing the math. You have to have this added here, and then it's minus the product of all of this. It's way better if you can enter it all at one time. So minus 2 times 5 times 9 times the cosine of 120. Folks, x squared is what we have there, and it is 151. We need x, so we'll take the square root of both sides and we'll get an approximation for this. So taking the square root, our side length x is about 12.3, and you can see that that makes sense in terms of the geometry here, folks. The longest side is across from the biggest angle, and that makes sense. Alright, so we've used the law of cosines to find a side length. If we're going to find an angle measure, what you have to know is all three sides. And in this case, we have that, all three sides. And I'm going to I like to have my formula solved for the angle, and I just want to remind you, you're seeing that on the slide above. But what it says is that the cosine of the angle that we need, x, will be equal to, and it's the opposite side first, 21.8 squared minus the squares of the other two sides, minus 19 squared minus 24.3 squared. All of that divided by negative 2 times the two sides not across from our angle. So negative 2 times 19 times 24.3. Again, this is something that can be entered into your calculator just the way it looks. What I would caution you about is that you need to divide everything on the top by everything on the bottom. So if you're entering it in all at once, you need the parentheses. 21.8 squared minus 19 squared minus 24.3 squared, close, all divided by negative 2 times 19 times 24.3. And there we have the cosine of our angle. So the cosine of x is about 0.5158. And to find x, we'll do the cosine inverse of that 0.5158. I'm going to use the answer function in my calculator because that's a little bit more precise. So second and cosine, second answer. And it says that my x is an angle that is about 59.0 degrees. Alright, now I would say here, if you had to go further and solve this triangle, you could find the other two angles using the law of sines. However, once you use the law of cosines to find an angle, the benefit to that is there are never going to be two triangles. If you use the law of cosines, you don't have to worry about there being two triangles to worry about. Just use the law of cosines to find those missing angles. It's much more, to me, straightforward. So that's it for our lesson today. I just want to remind you in closing that we have several tools for solving triangles. If we have a right triangle, we can use the Pythagorean theorem, of course. SOHCAHTOA, or right triangle trig, work in right triangles. If our triangle is not a right triangle, then the law of sines or the law of cosines are our man, and we'll choose the one that we need based on what our triangle looks like. In this one, you need an angle side pair. And in the law of cosines, there is no angle side pair. That's probably the best way to decide which we should use. Alright, I'm going to ask you to get out there and try that. You try at your earliest convenience. We'll talk about this in school tomorrow.